In this video, we'll discuss about the hypoxia. Define hypoxemia. The arterial partial pressure of oxygen below the normal levels is called as hypoxemia. Define hypoxia. It is the condition when partial pressure of oxygen within the cells is insufficient to allow normal aerobic metabolism to provide energy for cellular functions. Types of hypoxia: hypoxic hypoxia, anemic hypoxia, ischemic or stagnant hypoxia, histotoxic hypoxia. Hypoxic hypoxia. It occurs due to any cause of reduced oxygen availability to the hemoglobin. Anemic hypoxia. It occurs due to reduced oxygen carrying capacity of the blood. Ischemic hypoxia or stagnant hypoxia. It occurs due to perfusion failure. The causes are related to the heart or the circulation. Histotoxic hypoxia. The oxygen is delivered to the cells, but cells are unable to utilize it. First, we'll discuss about hypoxic hypoxia. The causes of hypoxic hypoxia are high altitude due to low oxygen tension, hypoventilation, ventilation perfusion mismatch, reduced oxygen diffusion in lungs. Let's discuss about the changes happens to oxygen dissociation curve in hypoxic hypoxia. The arterial point is shifted downwards. The partial pressure of oxygen of the arterial blood is reduced to 7.2 kilopascal. The saturation of the arterial blood reduced to 85%. And the oxygen content of the arterial blood is 17 ml per deciliter. The venous point, it also shifts it downwards. The partial pressure of oxygen of the venous blood reduced to 3.5 kilopascal. The saturation of venous blood reduced to 45%. And the venous oxygen content is 9 ml per deciliter. So there is arterial and venous desaturation. The anemic hypoxia, it occurs due to reduced oxygen carrying capacity of the blood. The causes are reduced erythrocyte count due to blood loss or bone marrow suppression, reduced hemoglobin concentration due to iron deficiency, abnormal hemoglobin, for example, sickle cell anemia, thalassemia, and reduced oxygen binding, for example, carbon monoxide poisoning. Now let's discuss what happens to the oxygen dissociation curve in anemic hypoxia. The arterial point remains same. The partial pressure of oxygen is normal, that is 13.3 kilopascal, which correspond to the saturation of 100%. However, the arterial oxygen content is reduced to 9.6 ml per deciliter, round figure as 10 ml per deciliter. The venous point is shifted downwards. The partial pressure of oxygen in the venous blood is reduced to 3.5 kilopascal. The saturation of venous blood is reduced to 50%. There is venous desaturation. And the venous oxygen content is 4.7 ml per deciliter, round figure as 5 ml per deciliter. Ischemic hypoxia or stagnant hypoxia. It occurs due to perfusion failure. The delivery of oxygen, DO2, is reduced, so more oxygen is extracted, leading to increased arteriovenous oxygen difference. The causes are reduced cardiac output due to hypovolemia or primary cardiac failure, microcirculatory failure, for example, sepsis, any other organ failure involving shock, vascular abnormalities like thromboembolic events or arteriovenous shunting, limb ischemia like peripheral vascular diseases, compartment syndrome, or use of tourniquet. Now let's discuss what happens to the oxygen dissociation curve in ischemic hypoxia. The arterial point remains same as corresponds to 100% of saturation, and partial pressure of oxygen in the arterial blood is 13.3 kilopascal. The venous point, it is shifted downwards. It corresponds to the saturation of 50%, and the partial pressure of oxygen in the venous blood is 3.5 kilopascal. The venous oxygen content is 5 ml per deciliter. So there is venous desaturation. Histotoxic hypoxia. The oxygen is delivered to the cells, but cells are unable to utilize it. Examples are cyanide poisoning, malignant hyperthermia due to mitochondrial failure. Malignant hyperthermia also shows ischemic hypoxia due to compartment syndrome induced by muscle swelling. Let's discuss what happens to the oxygen dissociation curve in histotoxic hypoxia. The arterial point remains same, corresponding to the saturation of 100% and partial pressure of oxygen of 13.3 kilopascal and the oxygen content of 20 ml per deciliter. The venous point, it shifts upwards. It corresponds to the saturation of 90% and the partial pressure of oxygen of venous blood is 8 kilopascal. The oxygen content of venous blood is 18 ml per deciliter because cells are not able to utilize the oxygen.